Okay, so this photo to show that initial crack at the B at the keyway of the B. So you can see from the part B, it start to crack. Okay, you can see the micro crack until very big crack at there. So this one is the cross section of the fill part. This one is going to fill rapidly. So or when you design it, you involve the hole. So a sharp corner there is there will be high concentrations. So normally the crack will happen at there. So this one also is a cross section for the fill part. Okay, this one, because you make a numbering, okay, it's a stamp mark at there. So at the location of this one, the mark, because you apply the force on that, so the crack is start to happen surrounding the words. Stamp mark showing heavy impress and the fracture extended along the words. Okay. Okay, this fill design to show that the crack is happen to this weak part. Start to crack internally. Fracture at the surface. And you can see inside the hole start to have a micro crack. Okay, so what is the approach for fatigue failure in analyze and design? Okay, while the scientist is not yet completely explained and the complete mechanism of fatigue. So we need to find out the design that make it will not be happen, will not be filled. So even though we cannot 100% understand, but we also need to design something to prevent it to be happen. Or before it's happened, we replace the new one. So fatigue, there are three parts. Okay, before that, fatigue life methods. So it's an analyze to predict when it will be happen, and the loaded machine component will fill in the fatigue over a period of time. Okay, so you use any part of the machine, they have their lifetime. So before the fatigue happen, we need to be take it as a consideration and replace it a new one. So what is the strength life diagram? We call SN diagram. It's a fatigue strength SF versus the N value, life cycle. Okay, so this one is a generate from the test. We will get this diagram generate from the test at the standard lab control specimen. So we will develop it. We want to find out what is condition. So is in SN curve, we will find out that this after some times of the cycle life end, the S will become horizontal at some point. This line is the we call endurance limits, SE prime. It's happened at 10 power of 6, 10 power of 7 cycle between the cycle value. So SE prime, endurance limits. But why got the prime there? It's a control laboratory specimen. It's a control lab. Okay, that means the specimen, we get it from the lab test. Okay, fatigue life method. So there are three major fatigue life method that we are using to observe. That is stress life method. Another one, strength life method, or linear elastic fracture mechanic methods. These three. So for the N value is from 1 to 1000 cycle. This one we consider as a low cycle fatigue. If there is a higher cycle fatigue that is more than 1000. Okay, stress life method based on the stress level only is the least accurate method. Okay, there are three major This one, the first one, is the least accurate and apply to low cycle application. This is the most traditional methods that easier to implement and wide range in the design. Faster, even though it's less accurate, but it's traditional way and can be easily to get the result to predict. Second, strand life method is involve more detailed analysis of the plastic deformation at the localized region where the stress and strain are considered for life estimation. This method especially good for low cycle fatigue application. Okay, it's good for low cycle fatigue application. Okay, another one, fatigue mechanics method. This assume that the crack is already present and detected, so we can predict the crack growth, especially for the stress intensity, high stress intensity. Okay, so basically we got three methods for different condition.